This is lesson 1.3, and we're on the third video, so 1.3c. And we're still dealing with trig functions. We're in example 3 right now. So I've got the xy axis right there. And the question for example 3 is find the 6 trig function values of the angle theta in standard position if the terminal side of theta is defined by x plus 2y equals 0. Okay, so let's make this bigger so that I can draw with my black ink on here. Alright, so it gives us a terminal side of x plus 2y equals 0, and x must be greater than or equal to 0. What that's saying is the terminal side is a line segment. Now remember what we said in the past in algebra. Every equation can be written or can be drawn on an xy axis. We can draw a picture of that equation. So this equation that we're going to draw here is going to be a straight line. And the reason we know it's going to be a straight line is because there's no exponent on the x other than 1. No exponent on the y other than 1. So that's telling me that we're going to have a straight line. Now, all I have to do in order to draw that line is, for one thing, I know one of the points is right here. Okay? For what we're doing, we're starting at the origin. So we've got one of the points. Alright, so let's go ahead and just stick in a number for x and see what kind of a y it spits out, or put a number in for y and see what kind of x it spits out. For this particular one, you could put in a y value. So let's say that we put in a y value of 3. So we get x plus 6 equals 0. Let's keep solving here. X equals negative 6. Problem is, we said that x had to be a number greater than or equal to 0. So that doesn't work. So not a real good idea to plug values in for y, because you might get negative numbers, and when you get a negative number like this, you start over again. So let's pick our x value, because we know it has to be bigger than 0. So let's put a 3 in here for x. So I know it's positive. Alright, so we get 2y equals, we're going to subtract 3 from both sides. We get 0 minus 3 is negative 3. Y equals negative 3 halves. So negative 1 and a half. So when x is 3, y is negative 1 and a half. So let's go over 1, 2, 3, down 1 and a half. And that gives me my line segment, or my terminal line there. So I'm good to go as far as finding out where in the world this equation, the line of this equation is drawn. So notice I don't go over here at all, because if I'm over here, what is my x value? It's negative, and it says here it has to be bigger than or the same as 0. So that's why I put an x in here that was greater than 0, and I don't care what my y value is, and I'm able to draw that ray. So notice when x is 3, y is negative 3 halves. Well, that doesn't look real good to work with, but look at this. It also crosses at 2, negative 1. Well, let's see if that works. Let's see if, because those aren't fractions. So let's put in a 2 for x, and let's put in negative 1 for y and see if that's true. Yes, it is. 2 plus negative 2 is 0 equals 0. So I'm going to use that one, because this one will work. It's just a nasty fraction, and I don't really want to mess with fractions. So let's just use the one that I have. And so that gives me a triangle. So this is 2. Let's do it in black. That's 2. That's negative 1. And then I can find out what this is. That's my r value by taking 2 squared plus negative 1 squared equals r squared, or take the square root of that, and I find out that this length here is the square root of 5. So that's my hypotenuse. So my x is 2, my y is negative 1, and my r, or my hypotenuse, is the square root of 5. So let's stick with those numbers, and I can just find my sine, cosine, tangent, cosecant, cotangent, and secant, my 6 trig functions, based on just what I have circled here in red. That, and that. And I've had some students do this. X is 2, y is negative 1, r is square root of 5. And now it becomes really easy to find your cosine of theta, your sine of theta, your tangent of theta, and then we also have, in fact, let's get rid of some of this junk here. And let's see what happens if I do that. And then we've got secant of theta, cosecant of theta, and cotang of theta. Okay, so cosine, we know from past notes, is x over r. Sine is y over r. And tangent is y over x. Secant is just the inverse of each of these. So secant is r over x, cosecant is r over y, and cotangent is x over y. So all I'm going to do is go up here and take these numbers and replace them for the x, y, and the r. And that'll give me my my trig functions. So let's do this. Let's just do this in blue. Sometimes that color change. X over r would be 2 over square root of 5. Y over r would be negative 1 over square root of 5. Y over x would be negative 1 over 2. R of x would be square root of 5 over 2. R over y would be square root of 5 over negative 1. And x over y would be 2 over negative 1. So there's all 6 of our trig functions. One of the things you do need to be aware of, remember you can't have a radical on the bottom. So for like 2 square root of 5, in fact let's do this up here, 2 over square root of 5, remember to get rid of the radical on the bottom, you multiply top and bottom by that radical. 2 times square root of 5 is 2 square root of 5. Square root of 5 times square root of 5 is the square root of 25. Square root of 25 is 5. So there's what you get for the cosine when you get rid of the radical on the bottom, 2 square root of 5 over 5. You do the same thing for the sine here, and then you'll have all 6 trig functions. Alright, one of the things that I want you to be aware of is the slope of any angle will be the tangent of theta. The tangent will always be the slope of that angle because it's y over x. If you remember, slope is y over x. The y value over the x value. So the slope of this line is going to be negative 1/2. So the slope of that is negative 1/2. Good to remember. It will come in handy in the future. So that's it for 1.3c.